students, welcome to Easy BTech, your guide for BTech and beyond. We are going to discuss subject signals and systems, and today's topic is we are going to do problems on Fourier series. Very important class for you. So before going to our class, please subscribe, share the channel. Let's start today's class problems on Fourier series. So before going to problems, I will tell you one point. In the previous session, we discussed even symmetry and odd symmetry. So this point is regarding to symmetry, even symmetry and odd symmetry. So if you take even symmetry, coefficients in case of even symmetry, Fourier series coefficients an is equal 4 by t integral 0 to t by 2, 4 by t integral 0 to t by 2 x of t cos n omega naught t dt. So in case of even symmetry, this will be the coefficients an. Now in case of odd symmetry, if you take odd symmetry, what will be coefficients bn? Now odd symmetry, in case of odd symmetry, Fourier series coefficients bn is equal to 4 by t integral 0 to t by 2 x of t into sin n omega naught t dt. Sin n omega naught t dt. So please remember an and bn in case of even symmetry and odd symmetry. Let's do one simple problem. Just a very small problem. X of t is equal to just sin omega naught t. So here the fundamental frequency is omega naught. Frequency is omega naught. And we know exponential Fourier series. What we know exponential Fourier series? X of t is equal to summation n is equal to minus infinite to plus infinite. Here coefficients cn e to the power jn omega naught t. So now I am going to write exponential Fourier series for the given periodic signal x of t. We are going to write exponential Fourier series. So how I am going to write is just as like a Euler's formula. Sin theta can be written as e power j omega naught t minus e power minus j omega naught t divided by 2j. So we can do it separately. So 1 by 2j e power j omega naught t minus or plus minus 1 by 2j e to the power minus j omega naught t. Exponential Fourier series. So I am writing the sine function in terms of exponentials as per Euler's rule or Euler's formula. And if you see here, exponential Fourier series, we have here. So if you open this exponential Fourier series, n is equal to 0, you get c0, and n is equal to 1, c1 e to the power j omega naught t, and n is minus 1. Similarly, n is minus 1. So we get c minus 1 c minus 1 e to the power minus j omega naught t, and so on, right? And so on, and so on. Now, what we have? This we have 1 by 2j e power j omega naught t plus minus 1 by 2j e power minus j omega naught t. So, by the comparison, by comparing with exponential Fourier series, we get the answer, nothing else. So, if you compare e power j omega naught t, so here e power j omega naught t, what is the coefficient here? We have C1. So, what is C1? Now, here 1 by 2j, just comparison, proper comparison. Carefully do comparison. We get coefficients. And similarly, C minus 1 means e power minus j omega naught t coefficient. So, here e power minus j omega naught t coefficient is C minus 1 is equal to minus 1 by 2j. Minus 1 by 2j. So, in this way, we can do Fourier series coefficients, right? And another simple example, let's take x of t is equal to 1 plus sine omega naught t, 1 plus sine omega naught t plus 2 cos omega naught t plus cos 2 omega naught t plus pi by 4. So, this is the given periodic signal. Here, what is the fundamental frequency? Omega naught is the fundamental frequency. This will be fundamental frequency, omega naught. Right? Now, as per Euler's formula, we can write x of t is equal to 1 plus sine theta can be written as e power j theta, that is e power j omega naught t minus j omega naught t e power minus j omega naught t by 2j, right? And similarly, cos theta can be written 2 into e to the power j omega naught t. So, here we get plus e power minus j omega naught t divided by 2. This is the cos theta. And again we have cos theta here. So, again e power j 2 omega naught t plus pi by 4, 2 omega naught t plus pi by 4 plus e power minus j 2 omega naught t plus pi by 4 plus pi by 4. This total is divided by 2. Okay. So, now here 2 get cancelled. So, what we are going to do is, we are going to write e power j omega naught t terms, e power minus j omega naught t terms, e power 2 omega naught t or 2j omega naught t terms, right? Separately we are going to write. So, now x of t is equal to 1 plus e power j omega naught t. I am going to write e power j omega naught t. So, here we have 1 by 2j. Next, again here we have e power j omega naught t. The multiplier is 1 or coefficient is 1. Any other e power j omega naught t? No other. So, that's all. In the same way, we are going to write e power minus j omega naught t terms, e power minus j omega naught t. So, here we have e power minus j omega naught t, and here minus 1 by 2j, minus 1 by 2j. Again here we have e power minus j omega naught t, it is 1, right? Next, e power 2j omega naught t terms we are going to write. So, before going to that 2j omega naught t, here we have plus pi by 4. So, that I am going to write like this, e power j pi by 4, e power j pi by 4 by 2 e to the power j 2 omega naught t, right? We can write like this. Again plus e to the power minus j pi by 4 by 2 and e power minus 2j omega naught t. Right? So we have written separately j omega naught minus j omega naught, 2j omega naught or 2 omega naught minus 2 omega naught. So this is the logic we have to follow, because our Fourier series is like, we have exponential Fourier series like n is equal to minus infinite plus infinite cn e power jn omega naught t. So if you expand it, if you take n is equal to 0, first c naught we get, and n is 1, c1 e power j omega naught t, and n is minus 1, c minus 1 e power minus j omega naught t, and n is 2, c2 e power j 2 omega naught t, n is minus 2, c minus 2 e to the power minus j 2 omega naught t, and so on. So likewise we get the terms in Fourier series. Now we are going to compare these two, just comparison, compare. So compare. By the comparison we can get the answers, we can get the results. What is result? C naught. What is the C naught here? 1. So first comparison, C naught is 1. And go on, C1. So here C1, j omega naught t term. So here we have j omega naught t. What is C1 now? C1 is equal to 1 plus 1 by 2j, or we can write as 1 by j as a minus j. So 1 minus 1 by 2j. This is the C1. And what is the magnitude of C1? Value of C1 under root of imaginary part square, real part square, or real part square plus imaginary part square. 1 square plus 1 by 2 whole square. I think it will be 5 by 2. Right? Magnitude I am writing, value. And similarly, C minus 1. So C minus 1 means here we have C minus 1 e power minus j omega naught t coefficient. So here e power minus j omega naught t, what is the coefficient or what is the multiplier we have? 1 minus 1 by 2j. So 1 minus 1 by 2j. 1 by j is a minus j. So it will become 1 plus 1 by 2j. And magnitude is same again, root 5 by 2. Root 5 by 2. And if you take the phase of C1, angle of C1, how to write the phase? Tan inverse imaginary part by real part. So what is the tan inverse here? Imaginary part minus 1 by 2 and the real part is 1, so minus 1 by 2. So we get the negative angle here. And angle of C minus 1, same way, tan inverse imaginary part by real part. Here imaginary part is 1 by 2 by 1, so tan inverse 1 by 2. We get a positive phase. I am telling magnitude and phase both, because we are going to plot magnitude spectrum and phase spectrum. That is why we are discussing. And in the same way, go on comparison C2. C2 means here what is the C2? E to the power j 2 omega naught. Right? So where is 2 omega naught here? 2 omega naught. What is the coefficient we have? 1 by 2 e power j pi by 4. So what is the magnitude of C2? Anyone? What is the magnitude of C2? 1 by 2. Right or not? 1 by 2. Because e power j pi by 4, cos pi by 4, j sin pi by 4, magnitude will become 1. So 1 by 2. And what about phase? Phase of C2. So this is the phase, j pi by 4. Pi by 4 is the phase. Right or not? It is like r into e power j theta format. R is 1 by 2 magnitude, theta pi by 4. That's all. Nothing else. And C minus 2. So how to say C minus 2? How to do C minus 2? So see here, C minus 2. E power minus j 2 omega naught t coefficient. So in our problem, where is that? Identify e power minus j 2 omega naught t. What is the C minus 2? This is the C minus 2. That red circle. So same 1 by 2. e power minus j pi by 4. Minus j pi by 4. So what is the magnitude here? 1 by 2 only. And what is the phase? C minus 2 phase? Minus pi by 4. Right? So this is the way, simple way of doing Fourier series or doing coefficients of Fourier series, their magnitude and phase. Let's go to continuation. I'm going to plot magnitude spectrum and phase spectrum. Magnitude spectrum and phase spectrum. So the values, coefficients values, 1, C0 is 1, C1 root 5 by 2, C minus 1 also root 5 by 2, C2, C minus 2, 1 by 2, 1 by 2. So spectrum, magnitude spectrum or magnitude plot. Magnitude spectrum. So here x-axis and y-axis. X-axis is the n value and y is the coefficients as per n. So n is equal to 0 means C0. Y-axis is magnitude of Cn. What is the C0 value? We have 1. So take that one. C0 is 1. So I am going to take 1. I am going to plot 1 at 0. Next at 1. C1 value. What is the magnitude of C1 value? Root 5 by 2. So take that at 1 root 5 by 2. Similarly at minus 1 also same root 5 by 2. And C2 1 by 2. So 1 by 2 here. C minus 2 also 1 by 2. Clear? So this is 2 minus 1 minus 2 and magnitude here 1 by 2. Here also 1 by 2 and here root 5 by 2. C0 is 1. This is also root 5 by 2. Next phase. I am going to plot phase spectrum. Phase spectrum. So already we know phase, we have seen individually, that we are going to plot. So here x-axis is n. Now at 0, C0 phase, C0 value is 1, so C0 phase is 0 because it is a real value, phase is 0. Next C1, what is the angle of C1 or phase of C1? See in the previous. So C1 is equal to how much? Phase tan inverse minus 1 by 2. So it will be a negative phase, right? Something negative. So I am taking negative phase. Okay. So how much it is? Tan inverse or minus tan inverse 1 by 2. Next, C minus 1 positive, which is equal to tan inverse 1 by 2 at minus 1. And C2 at 2, C C2 phase is how much? Pi by 4. C minus 2 phase minus pi by 4. So, right? C2 phase is pi by 4. C minus 2 phase is minus pi by 4. That we are going to indicate. Pi by 4 here. Pi by 4. And C minus 2 phase is minus pi by 4. So this is a magnitude plot, phase plot. So you can understand one point here. So both are magnitude and phase plot, both are discrete. That is the point. Both are discrete. Both are discrete. Right or not? Magnitude plot is discrete, phase plot also discrete. Right? So continuous time Fourier series we are discussing. Exponential Fourier series. We have taken a continuous time signal x of t and magnitude plot, phase plot, we got result discrete. We got result discrete. This is the point. Please remember. Next, we are going to do another problem. Find trigonometric Fourier series for the given periodic signal. Trigonometric Fourier series for the given periodic signal. So here I am taking periodic signal. This is a periodic signal. Again repeating, and so on. Up to infinity it will repeat. It repeats itself. That is why it is periodic. And similarly, left side also it repeats. And so on. Right? This is a periodic function given, periodic signal given. So here the amplitude is A. This is called sawtooth waveform. The amplitude is A. 0 here, 1 here, 2, 3, -1, -2, and the signal I am indicating as x of t. We want for a trigonometric Fourier series for the given periodic signal. So how to start? So in any problem, trigonometric Fourier series or exponential Fourier series, first we need to identify time period. Its time period. Well, how can you identify one cycle? We need to see, observe one cycle, one complete cycle, and take the time, that is time period. So this is the cycle, one cycle. So I am plotting with the blue. This is the one cycle, right or not? The same is repeating. So this time is 0 to 1 is the one cycle, which is the time period, capital T. So is equal to 1 second. So time is 1 second. Next, after identifying time period, go for frequency. So omega naught is equal to 2 pi by t, which is equal to 2 pi. Right? And again, after t and omega naught, we should write the definition of x of t. X of t expression or definition according to time period indicated. Where to where we have indicated time period. As per that or up to that time period interval or up to time period, we need to write the expression of x of t given signal. So if you observe x of t 0 to 1, it is a line, right or not? It's a line. So we need to write line equation. It is a line. So we have to write x of t is a line equation or line where to where 0 to 1. So how to write the line equation? And this line is passing through origin, right or not? It is passing through origin. So the line equation passing through origin, what is that? Y equal to mx. What is that line equation? Y equal to mx. So I am writing now the line equation passing through origin, y equal to mx. Here y means y-axis x of t. So y place is x of t. And t is the x-axis. X means t, time. And what about m? M is the slope of the line. y2 minus y1 by x2 minus x1. So if you consider points, this point will become 0, 0, and this point will become 1, a. So here x value 1, y is a. So 1, a. So now the slope is a minus 0 by 1 minus 0, it will be a. And x-axis is t. So this is the line equation 0 to 1. So after getting this x of t expression, we go for series. Go for series means we write the series definition, trigonometric Fourier series definition. In that definition, we have a naught, a and bn. Those we are going to do. Now, what is the trigonometric Fourier series definition? X of t is equal to a naught plus summation n is equal to 1 to infinite an cos n omega naught t bn sin n omega naught t. Bn sin n omega naught t. Let's do a naught, a and bn. That's all. After doing that, then we substitute in x of t. So a naught is equal to formula 1 by t integral here, yes, 0 to t x of t dt. So do this integration. T is 1, so 0 to 1 x of t is how much? At dt. So the integration of t square by 2, and the limits here 0 to 1. So by substituting upper and lower limits, we get a by 2. So this is the DC value or average value of x of t. A by 2 is the average value of x of t. So you can do this average value directly, right? See here, integration of x of t dt 0 to t means area of x of t 0 to t, right or not? Area of x of t 0 to t. So after that area, we need to divide by its time period. Then we get the a naught. This is also a correct or another way of doing a naught. So actually here 0 to 1 we have triangle shape, right? 0 to 1, and its amplitude is a. So what is the area of this? Area of this of BH. So of what is the base here? 1, h is a. So 1 into a. After this total is divided by time period. So the total is divided by time period is 1. So again 1 by 2 into a. So area of triangle of BH. Okay. The waveform is like triangle shape. That is why area. That area is divided by time period. That is a naught. Whatever a naught is there, we are following it. Next, an and bn we do. Go to an and bn. Now an and bn. So formula first we write. An is equal here 2 by t integral 0 to t x of t cos n omega naught t dt. So do this an. Now an is equal to 2 by 1 0 to 1 x of t is at cos n omega naught. What is omega naught here? 2 pi. So 2 pi t dt. So if you observe this integral, it is like uv, integral uv. So what is integral uv? What is integral uv? U integral v minus integration of u dash integral v. So that we are following now. Integral uv. So now here u is the t, v is the cos n 2 pi t. So go on that. An is equal to 2 into u integral v. So t cos integral or cos integration sine 2n pi t divided by 2n pi, because integration is with respect to t. So t 2 is for 2 is, we can write outside, minus u dash differentiation of t 1 integral v cos integration sine, again sine integration minus cos. So finally we get here plus cos 2n pi t divided by 2n pi 4n square pi square, and the limits is from 0 to 1. And go for substitution of limits, we get the a value. So 2 upper limit is 1. So 1 into sine 2n pi and cos 2n pi. 1 into sine 2n pi plus cos 2n pi. So sine 2n pi is 0. I am saying it. Here you get 1. Here you get 1. Upper limit. So sine 2n pi, how much? 0. So the first term is 0. Plus cos 2n pi. Cos 2n pi is 1 always. So that is why 1 by 4 n square pi square. So I am writing here sine 2n pi is 0, cos 2n pi is 1, always 1, cos 2 pi, cos 4 pi. If you take n value 1, 2, 3 and so on, we get 2 pi, 4 pi, 6 pi, cos value 1. And lower limit. So here t is 0, 0 is 0. and sine 0 is also 0, so lower limit 0. And here cos 0, what is the cos 0? 1. So 1 by 4 n square pi square. So this is the value an after substituting upper and lower limits. So here 1 by 4 n square pi square minus 1 by 4 n square pi square, cancel it. So an value is 0. This is the an 0. And we got a naught is a by 2. Let's see bn similarly. So what is bn? Formula for bn? bn is equal to 2 by t integral 0 to t x of t sine n omega naught t dt. Sine n omega naught t dt. So let's have t, x of t, all values, all the things. 2 by 1, 0 to 1, x of t is at, sine n omega naught is 2 pi, so sine n 2 pi t dt. So again it is like uv, so we can write integral uv. So you can write your 2a outside, 2a outside. Previously also we have a, yeah, a is outside, 2a. See here also 2a. And now, so 2a is outside, u is t, integral sine minus cos 2n pi t divided by 2n pi minus integral u dash t derivative 1 sine integration minus cos, again cos will be sine, minus minus will plus, will become plus, sine 2n pi t by 4n square pi square. So this is a uv integration and limits are 0 to 1. Substitute upper and lower limits. Substitute here into t into upper limit. When you take upper limit, so 2a upper limit is 1. Upper limit is 1. So 1 into cos 2n pi. So here we have minus sign. You can write minus outside. So 1 into cos 2n pi. Cos 2n pi divided by 2n pi. Divided by 2n pi plus this minus is for only cos, so I am keeping minus for cos. Plus again sine 2n pi, sine 2n pi divided by 4n square pi square. This is about upper limit. And if you take lower limit 0, so here t is 0, 0 into cos 0 is 0, sine 0 is 0. So lower limit value is totally 0. This is the thing we have. Now sine 2n pi 0. Sine 2n pi is 0. So this will be 0. Now only we have this one. So is equal to minus 2a by here 2n pi minus 2a by 2n pi cos 2n pi. Cos 2n pi. That's all. So cos 2n pi already we discussed, it is always 1. The value of cos 2n pi is 1. Cos 2n pi is equal to 1. So by this, what is bn? Here 2 get cancelled. Minus a by n pi. This is the bn. Minus a by n pi. So after getting a n, b n, a naught, we write the final solution. So x of t is equal to a naught plus summation 1 to infinite a n cos n omega naught t plus bn sine n omega naught t. Okay. Now, whatever the values a naught, a n, b n, we are going to write here. We are going to substitute. So a naught is equal to how much we have a naught? Just go to previous. A naught is a by 2. So write that a by 2 plus an is 0. So no need to write this 0 into cos n omega naught t. Bn, we have Bn. So summation 1 to infinite. Bn is minus a by n pi. So minus a by n pi sine n omega naught t. Omega naught is 2 pi. So sine 2 n pi. So this is the result we have. Okay. Very simple. Just integrations. If you know well integration, you can do Fourier series very easy. So thank you, students. Please watch videos regularly. You'll get easily understand. You can understand easily all topics. So all of you, please subscribe, share the channel. Thank you. Thank you all.